Hello everyone, I am Xiao Gang. Okay, let's look at this last part of the knowledge. We know the raw memory. Actually, regarding T2A, we know it creates these elements, and the space allocated in memory as a continuous one. T2A just wraps up the space here for you to use, providing you with some methods and information. But in reality, we can directly manipulate the space wrapped by T2A. But you better not do this, because doing this might cause some problems. We will explain what these problems are later. So if you want to do it faster, you can call this AddUninitialized, or the two functions InsertUninitialized. They can directly add this uninitialized space to the number. And this working method is the same as AddInitial, but it won't call the constructor of this type. If you just want to assign this area, you don't need to call that kind of function. Then you can consider using these two functions. We will now simply implement it for you all. Okay, we will put it here. Okay. And then over here, we have such a host. Okay, and what we need to do is very simple. We first move this code over here. On this side, it has declared the host for intersensor. There seems to be a small problem with moving it in this direction. It's because, let me take a look. Let me check it. Okay, it seems my project hasn't loaded here. I'll try refreshing the project here. It can recognize it. Actually, this group declared 1. This integer array, and in this place, a TLV was declared. Then inside the TLV, we add 4 natively initialized space elements, and then we overwrite the memory area here directly. Because their size and quantity are the same, we are essentially copying the memory directly over. Then we'll set up an endpoint here to take a look. Okay, let's start it. Okay, let's see what this is called. Okay, we'll set up the endpoint now and start it. Okay, after the startup loop, we'll come in. Look, it didn't bloom. Activate properly, right? Then after we add this bloom activation space, you will actually find that this value hasn't cleared. It hasn't cleared, right? Then let's carbon copy this over. Let's clear it out. Put the value in. So 2357 is correct. Then there are no problems here. Let's continue looking down. But what you need to notice is, if the struct in this place, do it like this. If you do it this way, this struct, you add this interlies, its structure. It won't initialize it for you. It only allocated just such a large memory area. We can give it a try. Let's use this structure here. We can see that we'll just use this structure. I'll use it. Let's first suspend the project. Then in this location, let's add it to the uninitialized. May. Let's add 4 to it. We need to add 4. Then you'll notice that it doesn't actually perform the initialization work. Actually, we can take a look at Where is this operation commonly used? Actually, it is most commonly used for our FColor, when we sometimes need to pass data from an FColor segment into it. We often use this thing. Okay, you can see that it is empty here now. And after we add 4 of them. Hey, you will notice, right? It did not execute the constructor because our construct body has this word. It didn't execute the constructor. These values inside are 17 million. Because there was no serialization, then let's continue looking at the bottom. So this is relatively dangerous. Actually, we often use this. Let me search for it, because I can include a practice session in this later code. We don't have this in our current project yet. Let's search for color, then Tori. Let me elaborate on this for everyone. This area. Let's take a look. This spot is a lock. It doesn't matter. What is this for? You see it, right? What is this? This is a class from OpenC. Inside the class, there is an array of fk2. These per reads the pixel. We use our run target to read the pixels. After reading them, so many elements were added here. Then it performs a reordered copy of the element in BGRA sequence. Because, as you know, it might have many different orders. Usually, we use ARGB or RGBA, but sometimes there is also BGRA. So in this place, it performs a negative loop, another type of reordered copy. So this function is most commonly used here. What is color? It is a struct. It contains 4 uint values, and it has some methods to represent colors. So this is one of the most common places we use it. Let's take a look below. Okay, this state machine is actually quite special. The most important thing is this operation. You shouldn't write code like this. This kind of code will have very serious problems. This is a very serious problem. It's just a C++ legacy issue. It just spawned an object, and then it leaks in the specified area. After spawning, you still have to manually execute the suction port, because we don't need to worry about calling this suction port technique. But if you handle it this way, it means you'll specify it in the memory region. Then you won't need to manually handle this memory region. And then finally, release the memory. Then let us execute the code for everyone. You don't need to learn this stuff. I don't even know why it's placed here. I think you shouldn't put this in the beginner documentation. But maybe because his document also didn't actually say it was for beginners, right? This is just a document written by experts. They thought they might need to share how it can be used this way. So they wrote and placed it here like this, orange too. Saw it and successfully created it. Okay, let's take a look. The creation location seems fine. Then we can take a look at how to write it. Here, an array is initialized. Then a 2-element item is added to the array, and then between these two inside, because this is index 0, this is index 1. At the position of index 1, look at this spot. Insert a specified number of uninitialized spaces into this array. 2 positions before index 1. Then the original position, 1 moves to 3, and then add 2. So this place gets the first value of the array, then to the position that is 1. This is to the position that is 2. Then 2f strings, 6 and 2, are passed, and then do it like this. It looks like there are no problems. We will demonstrate this to you later. Where is this problem? Line. Today we are going to continue calling. It should be area, okay? Okay. We had 2 elements like this, right? NPS. There is no direct way. This object is constructed directly using this parameter. Then add 2 spaces. Hey, look. These 2 spaces will show the results, though its value is problematic. So, make sure to remember. Then the other 2 objects, like this, you will find that ABCD is okay. Then next, we will demonstrate the problem here. We are still using this structure. Our structure should support direct negating a value directly, right? Yes, we can use inter to negate the value directly. We directly add. We don't need to add this element 4. I'll attach this first. Remember to rename it after you attach it. We'll just add 20. And then add 50. Then we'll also put an item in like this. Similarly, the location, we put it as the address of this array. And then we add a 99 to each one. Of course, our structural problem will definitely use this structure. Okay, no problem. Everything looks perfect. There are no problems with any of them. This side will execute the construction of this function 4 times. Then we go to the spot. Finally, when we run it, we display it here. All are released. Okay, let's observe the effect of our execution. Then let's go this way. If we execute it, let's think about it. It can be executed directly. This place should be, if not saved. We will pull it down. Okay, if not saved. Let's save it like this. We'll write this part. We can ignore the previous steps and just go to this part. Okay. Let's add 2 data points. Now there are 4 elements. 25, 10, no problem. We'll put 6, 2, and 2 in. So now it is ease. Hey, you can see there are no problems, right? Take a look. Oh, 2919. This place might. If we add 1, it seems we missed a line here. It seems we haven't allocated space for it yet. We should allocate 1 for it. Add another space. Something must have been missed here. There seems to be a problem here. Let's execute it again. Let's execute it again on our end. Okay, let's go down. Here though, add 2 words. No problem. After we add 2 regions, there are 4 in the middle 1 and 2. Actually, it's an undefined state that hasn't been digitized. Then let's take a look at. It's okay if this place becomes 99. It's okay if this place becomes 88. And it's okay if our constructor is executed 4 times. We will make anti-null. Originally, they were all released. Then that's fine. Proving that the constructor should be executed correctly. But you shouldn't use it like that. Right. Maybe this section executes for you. It takes this situation into account for you. So it executes this. Destructor within the structure. Okay, what I want to explain to you is this issue. Let's set aside what was mentioned above for now. It's actually like this. For example, this usage might have some potential issues. Don't use it like this. We allocated a 4-byte memory space like this. Then we use this indexing operator and reserved an object like this in this location. Then we have this space. When we delete it this way, it will not trigger the absorption. As you can see, if we execute it here, you can see it executed like this. Then we will jump straight down. Oops, it skipped it. Let's try that again. We'll go back to this spot. Everything before is normal. Let's go all the way down here. See that your life needs 4 objects, and then release all 4 of these objects. But if you go down, if your life only needs 1 object, that's fine. But if you change this memory area incorrectly now, you can see that 7 functions in this component did not execute. Also, there is another potential issue. For example, if you place other things in this memory region, if you put other things there, overwriting it like this will also cause issues. Overall, using the 6-bit operator has these 2 problems. So when developing with us, you should just avoid using it that way. It mainly emphasizes this issue. Okay, let's take a look at this. This AddZeroed and InsertZeroed. It mainly helps us to zero out the things inside. Then we can try it simply. Let's take a look. Right, and then we'll add a new function here. This method we call zero error. Then we copy the code. Then in this place, it initializes an internal structure. This structure can only be used here, which is equivalent to being declared at 0. Then in this place, we added a 0 after all the objects have been added here. It allocated something equivalent to 1, right? Can you take a look? Add a new object to the end of this data. Then it might resize this data. Then this new object will be cleared. And it won't execute this constructor, so we won't dispose of it. Because it doesn't execute the constructor here. You can't see anything. We should still use this structure here. We can see the constructor. Let's execute it now. Wait a moment. Before we execute it, we added another one. Let's see if it calls the purchase function. Let's change the name. Delete this. We will execute now. Actually, look at this place. It will clear this float to 0 web. Then the pointer is cleared to a null pointer, and then int312 is cleared to 0. Like this. Then we do this here. We write 1 here. We set a beta. Let's scroll down. We'll clear this part. How do we clear this value? Let's actually take a look. It should have a clean function. What kind of number is in this spot? Let's add a 0. You can see that it already has an element, but it hasn't executed its constructor, but its trigger was executed. So this is quite and also a relatively dangerous operation, because you cannot control its correct construction and the timing of its trigger, but it is also actually very useful. That is, when we deal with numerical data types, you can first allocate an area, zero them all out. So this is what it's used for. Let's look at the next part. Then there's uninitialized and clearing. Actually, they're all similar. It means that it expands the capacity. If the elements are expanded, if they exceed your current capacity. So it is either uninitialized or reset to 0. Then we can see this part. It sets the capacity to 3, and it performs another dangerous operation with 6. We shouldn't follow it. It performs a resizing here. Then, if it resizes, it will look like this. This side specifically emphasizes that we should use this carefully, because it can cause some unknown behaviors. And this function is generally used for a fixed structure within these structures. That is, when I initialize my RGB values. And want to set all of them to 0, or when a continuous stream of data needs to be set to 0. This is generally only needed in this case. Next, let's look at this behavior. It sets the number of uninitialized ones to 3, and here it's equivalent to the shadows for 1 and the shadows for 2. Put 2 other objects into this area. Yes, leaving 2 objects inside, then letting these 2 objects go in. This area has also been expanded. We can perform this operation. We should go back to our place here. As for here, next, let's change it to a end. Let's copy this here. First, we need to copy this. Let's use its struct. We won't force it anymore. I won't emphasize this problem of suction purchase and hooking again, because the previous 2 were already demonstrated. So this is the structure, and then it added an element of 0. Now it sets the capacity to 3, and then added 2 more elements. Now it sets the capacity to 5. So it's essentially resizing the capacity. Right? Then, what if we set the capacity to 2? Now let's take a look at the results of this execution. Let's test it now. Okay, we have opened it now. Then let's open one here. Hot second floor. Hit init and set a breakpoint. For this location later on, we will start executing now. Okay, good. This location spawned a host. No problem. Then add an element with a value of 0. So the capacity is 4 because we added it here, actually. Then let's first set the capacity to. It didn't say it. It doesn't actually have that. It's basically taking these two and adding 2 more. Right, its maximum capacity is still 4. There is now a slack element and the other 2 objects into this memory. Okay, that's fine too. And then we now put 8. If we set it to 5, it should also expand the ones, right? Do we still remember how the 16 expansion was achieved? You must still remember. We should have covered this in the previous video. This place is equivalent to 5 elements. So we expanded 2 of these elements. Then if we expand it to 2, let's look at the execution result. Okay, it's equivalent to the 3 elements after it being directly converted into, it's like they were cut out, deleted. Okay, so this is basically some methods for our entire TArray. And here there is some supplementary knowledge. This place is mainly used for this work size. It is a serialization function. It can serialize the array as raw bytes instead of serializing element by element. If it is a primitive type, then greatly improves this performance because it's like serializing everything all at once instead of serializing every single element. We can take a look at it actually in this part. What you mainly need to remember in this area is a class like this. We can go into our code. This part is an archive. What is archive? It's an excellent serialization method of its own. It can serialize data from and to the disk. You can see the best class for archive can be loading, saving, and then the garbage collection. And then, according to this white orders, nature of array. Okay, so this class is actually something we will use in many places. You can search for it. The knowledge in this area is quite deep. You can see that many of these have a UObject serialization interface. So we need to pass an object of this kind of class, and inside the serialization interface, you can find that it defines many things. It will define some of the things inside this class, just how to serialize it. So I'll just briefly explain this. Similarly, as you can see, what we often use is get local to get the size of the memory it occupies. Actually, you can get the memory size it occupies, and also in this counter by type, and here it actually passes an arch style, which means that when it serializes, it will use this thing. And at the same time, we also have one more swap and swap memorize, such we still have some other things. Next episode, we can continue it for you all. Let's talk about swap and swap memorize together.